Hey guys, Satyajit Pattnaik here and welcome back to my channel. And today's topic is going to be on one of the libraries which is used to semi-automate your machine learning tasks. So let's get started. Now, many of you might already be using machine learning exercises, machine learning algorithms like classification algorithms or regression algorithms. And we already know that when it comes to classification or regression, there are so many algorithms to deal with, right? XGBoost, decision trees, random forest, knife base, SVMs. When it comes to regression, again, linear regression, polynomial regression, XGBoost regressor, decision tree regressor. So a lot more models are available, lot more algorithms are available. And most of the times we have to call one model after one model, and it is quite a tedious task, right? That is a reason we have so many automated libraries in the market. And today we shall be discussing about one of the libraries, which is called as LazyPredict. I have used it personally. To some extent it eases off a lot of work, but it is not a fully automated library, but you can call it as a semi-automated library. So what exactly is LazyPredict? Before talking about LazyPredict, a huge shout out to the one who have created this blog on Analytics Vidya. His name is Ronil Patil. And based on this vlog, I will be doing some code walkthroughs, which is taking references from this blog. And this is Ronil's profile. I'll also leave Ronil's profile in the description below so that you can connect with him and talk to him. And let's get started with the main agenda. Now, introduction: if you are working in the field of machine learning or data science, then you are definitely at the right place. Selecting the best model for your machine learning problem statement is one of the difficult tasks. We already know it. First, you have to import all the libraries, then tune the parameters, then compare all the models, decision tree, random forest, XGBoost, which model is giving what type of accuracy. So it's quite a tedious task to call each and every model again and again and again. So to avoid this problem, LazyPredict provides you a lot of features. What exactly is LazyPredict? It's kind of a library which internally has a lot of existing libraries in between that. And when you call LazyPredict, it goes through a lot of classifiers and regressors, and it gives you a list which shows you what is the accuracy per available algorithm. Okay, so LazyPredict, what exactly is LazyPredict? We will be taking reference from this particular file. It is one of the best Python libraries that helps you to semi-automate your machine learning tasks. It builds a lot of basic modules or models without much code and helps understand which models works better without any hyperparameter tuning. Okay, and as I have already told you that this is a semi-automatic process. You get a list of your algorithms, who is working on how much, like what algorithm is giving you what kind of accuracy. Once you know that, oh, these are my 20 libraries or 20 algorithms which are giving these kind of results, let's try to take the top 5 and then do a hyperparameter tuning, right? So when you first start using LazyPredict, you have to install it. And you can see when I am installing the LazyPredict, a lot of libraries are getting called internally and they are getting downloaded. Pandas, TQDM, SciPy, scikit-learning, a lot more. Okay, moving down to the next section. Okay, so first we will be talking about classification, how LazyPredict works on classification problems, and then I will talk about regression. So if you are calling multiple models, like installing the libraries, importing the libraries, reading the file, doing some feature scaling process, and then calling your training and test split, then calling models. Model 1, model 2, model 3, and let's say you're calling 10 models. So the number of lines are huge. When it comes to LazyPredict, the number of lines are decreased, right? You just have to call one LazyPredict function and then it will give you an output. So let's get started. I'm importing my LazyPredict algorithm or LazyPredict library. Here I'm also importing LazyPredict library, LazyPredict classifier, which is LazyPredict.supervised. And I'm also importing, okay, this is a repetitive thing, so I can just ignore one. And I'm also importing sklearn data sets to get an existing data set, which is breast cancer prediction. And then I'm calling model selection to do our training and test split. And here I'm using data equals to load breast cancer to load the data. Once my data is loaded, you can just use this function. And then once your data is loaded, you can just check out your data. This is what your data looks like. It's in a different format. So what we are doing is we are doing x equals to data dot data and y equals to data dot target. Once that is done, you can just print your x to get your x variables and print your y to get the y variables. Okay, y is your dependent class, which is dependent on your x variables. Here I'm calling the training and test split to do the training and test split. Of course, people might be already knowing about this. Here I'm calling my lazy classifier. Now here there is a small change. After our training and test split, let's say you are calling your decision tree classifier, right? So you have to use like this, like sklearn dot tree import decision tree classifier, and then you call CLF equal to decision tree classifier. This is how we used to do it, when we are calling each and every algorithm. And then we do fit on my training data, y train. And once the fit is done, then we do y pred equals to CLF dot pred. Okay, predict. And then we pass our x test data. This is what we used to do. And similarly, if you are calling your random forest, you again have to do a similar kind of thing. You have to call your random forest classifier. And you can see how many lines of code are being used. For each and every model, at least you need 3 to 4 lines, right? So I'm just ignoring them. Instead of that, I'm calling lazy classifier. So once my lazy classifier is called, simply you can call your models comma predictions equal to CLF dot fit x train x test y train y test. You pass these features and print models. Automatically the models are getting printed. Of course, the models, it has some dot dot dot. So let's try to only print the models. You can see internally it has called multiple algorithms. Linear SVC, perceptron model, which is a neural network model, logistic regression, SVC, XGB boost, label propagation. So all these algorithms are called, and you can see for each algorithm, you can find the accuracy, the balanced accuracy, the ROC AUC value, F1 score, what is the time taken. And this is the beauty of lazy predict. You don't have to call each and every classifier separately. You are just calling lazy classifier and it is running through multiple classifiers and giving you the result. So from the above models, we can pick the top 10 models or top 5 models and train them or tune the parameters for better accuracy. So you get an idea which are your top performing models, and then you can take them and then you can do the manual processes of hyperparameter optimization and stuffs like that. Okay. Now, how lazy predict works on regression models. So similarly, I am using lazy predict supervised import lazy regressor. Let me just do it. Here I'm using a Boston data. I hope everybody knows about Boston data. Here I'm doing a training and test split. Okay, not training and test split. I'm just splitting the data into X and Y. And here I'm doing a training and test split. And here I'm calling regressor, lazy regressor. And here I'm calling predictions. So similar ways, like just few lines of code, and you can see all your models are ready with each models as adjusted R square value, RMSE value, and the time taken. And of course, you can just analyze all these things. Whichever model looks to be good to you, maybe SVR or bagging regressor, take that and then do your hyperparameter tuning. So this is all about lazy predict. There are other AutoML libraries as well, which makes your life even easier. So my recommendation would be you can get started with these kind of libraries, but of course, none of these libraries will be like an end-to-end kind of concept. You cannot use these libraries to finalize your model, but at least it will give you some initial intuition about your use case, about your initial models. And then ultimately hyperparameter optimization is where you enhance your model, and your that's going to be your work as a data scientist. So again, this is just an option. Many people also don't opt these kind of libraries because they don't trust, but it's up to you. It's up to you. It's your call. My work is to just show you the available libraries and available options there. That's it. If you like it, please like, share, and subscribe the channel. And in case you have a requirement of any sort of videos, comment down in the comment section below and I will definitely create a video on that. That's it for this particular video. Thank you. Bye bye.